Heterogeneous equilibrium. So far, we just talked about the equilibrium with homogeneous systems, where all the species components in the reaction were in the aqueous medium. But let's look at a reaction like this. The carbon dioxide gas is in equilibrium with carbon solid and with the carbon monoxide gas. So we can just write the equilibrium constant like this. So we take the product concentration in the numerator and the reactant concentrations in the denominator. But the concentration of a solid unit is actually a constant. So we can rearrange this equation and we can get this as again a constant. Therefore, the components with solid phase or liquid phase, they are not included. They do not need to be included in the equilibrium constant expressions, because the concentrations of a solid unit and a liquid unit is are also a constant. So we do not include those in the equilibrium constant expressions. Let's write the equilibrium expressions for those the heterogeneous uh, equilibrium systems. So here, this is a solid unit, calcium oxide, so we don't need to include that. And calcium carbonate is again a solid unit. So the equilibrium constant only equals to the concentration of the carbon dioxide. Look at the next one. Yes, this is in liquid phase, so the concentration of that is a constant. So we only need to include these two in the equilibrium constant expression. In C, iron is a solid, H2O liquid, F2O3 is a solid. So those species do not need to be included in the expression. Only the H2 gas is included. Um, the last one, this is in liquid phase, so it doesn't have to be included. So there is no product, so it will be only the 1 over the here for this equilibrium expression. Next, we're gonna play with these equilibrium expressions. Look at this equation. This is, uh, we can write the equilibrium constant expression for this reaction like this. The exponent, coefficient was the exponent here, coefficient is the exponent here. Right. Look at the next reaction. What is that actually? Yeah, you can just write the equilibrium constant. Yes. Now, what is the difference between these two? Yes, the sides were only swapped. Yes, actually, then we can say the new equilibrium constant is actually the reciprocal of the original equilibrium constant. When the side is uh, switched, the equilibrium constant becomes the 1 over of it or the reciprocal of it. Next reaction. Here we write the equilibrium constant expression for that one. Look at this one. What had happened? Yes, if you look at these coefficients, the coefficients were double. Yes, now we write the equilibrium constant for this. What is the relationship between this and this? Yes, actually the equilibrium constant was squared. When the amounts were doubled, the equilibrium constant will be squared. That is the relationship. Um, Now look at these two reactions. This is reaction A, this is reaction B, and here the reaction A was added to the reaction B in here. Right. Here this is the equilibrium constant written for that the total reaction. Yes, when the reactions are added, the product, the equilibrium constants expressions will be multiplied, or the product will be equals to that the total of the total reaction. The equilibrium constants will be multiplied each other. Here is the summary of the the manipulation of the equilibrium constant expressions. Please take a look. Okay, here if we, this is only the other one. If the amounts were halved, the equilibrium constant will be equal to the square root of the original one. Here is a and the following reactions have indicated this equilibrium constant, and calculate the equilibrium constants for the given expressions for the following reactions. What is the relationship between this and this? Yes, that is actually the change of the sides. So what would happen? Yes, you will take the 1 over the reaction, the equilibrium constant. Next one, 4NOBr, 4NO. Yes, what is the relationship between this and that? Yes, the amounts were double. So what should be done to with the equilibrium constant? Yes, it must be squared. Yes. Next, what is the difference between the reaction C and the that one? Yes, now it was halved. So the amounts were halved. So the equilibrium constant would be equal to the square root of the original one, like that. Please review those things and to get the correct answers.